Hello guys, welcome to my channel. Please, after watching this video on proof by mathematical induction, please don't forget to subscribe, if like, comment and share these videos. Remember, we are still on mathematical induction, right? You want to prove the summation of r is equals to 1 up to n. 3r minus 2 is equals to n over 2 multiplied by 3n minus 1 for all positive negative values of Z. So what you're going to do is say remarks. Remember, say remarks is awarded. So before you start watching this video, please subscribe and turn on your notification button if you like this video. So we are given this sign. This sign represents summation. So we are proving summations by mathematical induction. So we are now proving summations by mathematical induction. Just note that under proving summations by mathematical induction, we are going to focus on two concepts. The first concept is here on this video. On the next video, we're going to see the other concept of summations, proving summations by mathematical induction. Please don't forget to subscribe whenever you are watching this video. Right. So we are saying solution. So remember, we are under mathematical induction. So whenever we are working with mathematical induction, remember three steps. Assume true for n is equals to 1, assume true for n is equals to k, assume true for n is equals to k plus 1. So let's now assume true for n is equals to k. Assume true for n is equals to 1. For n is equals to 1. Right? To assume true for n is equals to 1. So we are saying left hand side here and also right hand side here. Right? So left hand side we are taking this thing. So we are saying 3r minus 2. Then right hand side we are taking this thing with n over 2 multiplied by 3n minus 1. But remember, we are saying we are proving, or we are assuming true for n is equals to 1. So we are saying whenever n is equals to 1, so we are saying 3 multiplied by 1 minus 2. This is equals to 3 minus 2, which is equals to 1. Then on right hand side, we are saying n is equals to 1. So we are saying half of 3 times 1, which is 3 minus 2. So 3 minus 2, which is 2, 2 over 2, which is equals to 1. So since left hand side is equals to right hand side, as you see, left hand side is equals to right hand side. Left hand side is equals to right hand side, hence true for n is equals to 1. We are done with the first step. Assume true for n is equals to 1. Let's now assume true for n is equals to k. So assume true for n is equals to k. Assume true for n is equals to k. Assuming true for n is equals to k, we are saying the summation of r is equals to 1. Here we have k. Instead of writing n, we are saying n is k. So is 3r minus 2 should be equal to, whenever this side n is equal to k. So we are saying k over 2 is multiplying which value? Multiplying 3k. Remember, n is equals to k. 3k minus 1. So we are done with assuming true for n is equals to k. Let's move on. Assuming true for n is equals to k plus 1. Let's move on. Assuming true for n is equals to k plus 1. Assuming true for n is equals to k plus 1. We are done with assuming true for n is equals to k plus 1. Assume true for n is equals to k plus 1. We are now assuming true for n is equals to k plus 1. So here we have, instead of n, we have k plus 1. So we are saying the summation of upper limit k plus 1. R is equals to 1, 3r minus 2, which is equals to, but remember n is equals to k. So we have k plus 1 over 2 is multiplying which value? Is multiplying 3 multiplied by k plus 1 minus 1, which is equals to k plus 1 over 2 is multiplying, we have 3k plus 3 minus. So 3, we have 3k, right, 3k, here we have 3k plus 3 minus, so we have 3 minus 1, which is 2, plus 2, right? So we have assumed true for n is equals to k plus 1. Let's move on to, we have assumed true for n is equals to 1, assume true for n is equals to k, and also assume true for n is equals to k plus 1. Whenever we are done with those 3 steps, what we have to do is we have to move on to the proof stage. So we want to prove After proving, you see the answer should be equal to this answer. So working on the proof stage. So on the proof stage, you are saying, right, proof, we want to prove. So whenever we want to prove, we are saying we are taking the expression, we assume true one is equal to k. We assume true one is equal to k, right? The here is, we have k over 2 multiplied by 3k minus 1. So we are adding k plus 1 the term. So on proof stage, just add k plus 1 the term plus n plus k plus 1 the term. K plus 1 the term. So want to see where to get k plus 1 the term. So whenever you want to find what's your k plus 1 the term, just go back to your final question, then substitute here whenever r is equals to k plus 1 the term. So just substitute r by k plus 1. This is your k plus 1 the term. So we are saying this is equals to k over 2 is multiplying 3k minus 1 plus, remember k plus 1 the term, substitute here, so it becomes k plus 1. So it seems like 3 is multiplying k plus 1 the term. So 3 is multiplied by k, we have 3k, we have 3k plus 3 minus 2 plus 3 minus 2. Alright. Then this is equals to k plus 2 is multiplying 3k minus 1, then plus 3 plus 3 plus 3k plus 3k. This one becomes plus 1. Right. Now we have this expression. Right. We assume true for n is equals to k. Right. Okay. So what we have to do here is we have to, this one can be written in the form 3k squared, just k multiplying this thing, 3k squared minus 2 all over 2 plus 3k plus 1. Remember, our final solution should be equal to this solution. Our final solution should be equal to this solution. And this will tell you that we have proved by method of induction. Right, let's consider we have 3k squared minus 2 all over 2 plus 3k plus 1. What we have to do is we want to find the lowest common denominator. Remember, this one is over 1, is over 1. This is equals to lowest common denominator, which is 2. 2 into this one, it becomes left with the 3k. We left with 3k squared minus 2. Then 1 into 2, which is 2. 2 times 3, which is plus 3. Plus 1 to 2 is 2 times 6. 2 times 3 is 6k. Then 1 into 2, which is 2. 2 times 1 is plus 2. Alright, right. So we have this one. So this one is equals to k. So this one is equals to k. This one is equals to k. Alright. This one is k. From this, k is multiplied by 3k, which is 3k squared. 3 times k times 1, which is minus 1k. Yes, here we go. Right. From this concept, we have 3k squared minus k plus 6k. We have plus 5k plus, then we left with the 2 here, all over 2. This is equals to, let's now factorize 3k squared plus 5k plus 2. We want to factorize this one. We want to factorize. I'm rubbing, we assume true for n is equals to k plus 1. We want to factorize 3k squared plus 5k, right, plus 2. Right, we want to factorize this thing. So factorizing, we are saying this one by this one, which is plus 6k squared. So we want to find the factors of 6. If you multiply those two factors, they will give us 6, and if you add or subtract, they give us 5, which is plus 3 plus 2. So we are saying 3k squared plus 3k plus 2k plus 2. Right? Factor out 3k. Then we left with k plus 1. Factor out plus 1. Factor out plus 2, I mean. Then we left with k plus 1. So these brackets are equal. So we have 3k plus 2 in brackets, k plus 1 in brackets. So this is how to factorize, simple factorization. So we are saying 3k plus 2, and we have k plus 1, but all over 2, right? Let's factor out. Remember, this one should be equal to this. We assume true for is k plus 1. So in order this expression to become this one, so let's factor out k plus let's factor out k plus 1. Let's factor out k plus 1 over 2, which is equals to k plus 1 over 2 multiplying 3k plus 2. As you see, this expression is equal to this expression. Hence, true for n is equals to k plus 1. So, which is equals to right hand side. So we have assumed true for n is equals to 1, true for n is equals to k, true for n is equals to k plus 1. Then we have take the proof stage where we said we have to take the expression on right hand side of where we assume true for n is equals to 1. Then add the k plus 1 the term where you substitute k plus 1 here to find k plus 1 the term. Then add, then simplify. Whenever you are simplifying, make sure your solution should be reduced to this form. You can apply what is possible so that it reduces to this, right? So since all stages are also true, right, then we can move on to the conclusion stage. We can move on to the conclusion stage. So for the conclusion, we are saying since true for n is equals to, since true for n is equals to 1, n is equals to k, n is equals to k plus 1. So we may say hence true for all positive integral values of z. For all positive integral values of z. So this is how to prove summations from the first situation. We are moving on to the second situation on the second video. So this is how to prove summations using this situation by mathematical induction. So please guys, after watching this video on proving by mathematical induction using this situation, please don't forget to subscribe. If you like, comment and share these videos with your colleagues. So thank you guys. Thank you. Enjoy these videos with others. Thank you so much.